33, geometric sequences. So arithmetic, let's change to this color. Arithmetic sequences is they have a common difference. So this is a consistent number added, constant number added, add, or common difference, they're saying the same thing. However, geometric, now we're talking about multiply. So it's the one first number would always multiply by a constant number and to get the next term. In other words to say is that we use the second term to divide it by first term. We got a number, and then the third term divided by the second term, it will be the same number. In that case, then this list of the numbers is a geometric sequence. For example, this one divided by that give us 2. 12 divided by 6 give us 2. 24 divided by 12 give us 2. All right, so, and now we're not talking about the common difference, but we're talking about the ratio, the common ratio. So the consecutive terms between the two connecting terms, the ratio is always the same, so it's constant. All right, so that means A2 divided by A1, if that's R, we use R as a ratio. Then A3 divided by A2 has to be the same R. The AN divided by AN minus 1 is still AR. Okay. Now here we say, okay, well, if that's the case, again, I prefer to use this as AN. I still don't understand why they need to use TN, because they're saying the nth term, probably they think use TN is better. But nth term, of course, is AN. So AN now equals to A, which is your A1, and then this is your common ratio, now N minus 1. All right, so how on earth this is this? So let's see how we can now derive this, okay? So I go to this page, let's just write out how to derive this so-called formula. Okay, so here we go again. So we have A1, not just A1. Now our A2 equals to A1 multiplied by that common ratio, and where A3, that equals to our A2 multiplied by that common ratio, right? However, now what is A2? Now A2 is also A1 multiplied by the common ratio. So that means A1 multiplied by R, and then there's another R multiplied by R again. So we got A1 to R to the power of 2. See that? Okay, well, this is power to the 1. So then we say, okay, well, what is our A4? A4 is our A3 multiplied by the common ratio. Okay, well, then our A3 is this. So that means that A1 multiplied by R to the power of 2 multiplied by another R, then that means A1 multiplied by R to the power of 3. So you see the pattern now is absolutely started showing up. So you have a A2, and this is A1 here, and then your power is 1 degree lower. You have a A3. Yes, there's still A1 here. Your power is 1 degree lower. A4, A1 degree is 3. Therefore, draw a conclusion. AN is prove. You keep writing all this, and then that equals to, of course, if AN is a n minus 1 multiplied by R, but then this n minus 1 it is you go back, forward, and then I'll trace back to the A1 to the R. If this is n, then this is n minus 1. So that's our formula. So our formula is an equals to a1 and this common ratio n minus 1. Okay, well then using this, now we can calculate different things. Okay, so now let's go back, take a look at our workbook. Okay, now again and again, so the sequence is given, it's geometric sequence, and then find the 8th term. So then you know where the term is, it's 8th term, and then you got the term value. And just plug the number in. Or they tell you the 4th term is that, the 9th term is that, find the 13th term. Then in this case, you got to figure out what is the common ratio here. You also need to figure out what is the first term, and then you're going to use that to calculate the A13. Okay. Now this question might be a little bit more interesting. It says what kind of value x so could make this x and this would form a geometric sequence. Now by definition, if they are geometric sequence, that means this divided by that should equals this divided by this term. So that means this divided by that equals to this divided by that, and then cross multiply, and it becomes a quadratic equation. Solve the quadratic equation, then you got two numbers, x either -1 or -4, and then these 3 terms will make a geometric sequence. All right, and then it's your exercise. Have fun.